Okay, we've got this straight line here, and then we've got a curve, which is actually a quadratic, but they've just called it a curve here. Part A, find the equation of the straight line. Right, and any straight line can be written as y equals mx plus c. So we need to work out the gradient. How many do I go along? I go along 4. How many do I go up? I go up 3. M equals rise over run. So it's going to be, our rise is 3 and our run is 4, so we've got 3 over 4. So I can write down that y equals 3 over 4x. Now my c is where it crosses the y-axis because it's when x is 0. In this case, I get it really quickly. Sometimes you have to do a substitution to try and work it out, but in this case, it's just going to be 2. So that is our answer. Y equals 3/4 x plus 2. The equation of the curve is y equals x squared plus kx plus 8. Find the value of k. Aha, this is where we are going to have to do a substitution because I've got a point on the curve, minus 4, 12. So I know when x is minus 4, y is equal to 12, and I can substitute that into here. I'm going to get 12 equals minus 4 squared minus 4k plus 8. That's going to give me 12 equals 16 minus 4k plus 8. Just going to move over to the left hand side to finish this off. So I'm going to get 12 equals 24 minus 4k. I'm going to minus 24 from both sides, so minus 12 equals minus 4k, and then I'm going to divide through by minus 4, so k will equal minus 12 divided by minus 4, and that is equal to 3. Diane draws line BQ. Okay, let's do the same. She says triangle ABQ is isosceles. So let's also draw that ABQ. Okay, how are we going to do this? Well, we need to show, I think there's a few ways. Okay, let's first of all find where Q is. So Q is going to be the point at which x is equal to 0, and it's going to be this number here, this 8. Q is going to be 0, 8. Because it's like this number here is always basically where a polynomial will intersect. A polynomial such as a linear line or a quadratic like we've got here will cross the axis. All right, I can see 2 ways we could do this this next question. I think I'm going to do it a really careful way. I'm actually going to find the length of each line. So I'm going to use Pythagoras, and AB will equal 4 squared plus 3 squared, square rooted, and that, if we get our calculator, well, that's going to be 16 plus 9, which is 25, square root it, we get 5. We can put it into our calculator if we want. We're going to do a similar thing for the top one, and again, we're going to go along 4, and we're going to go, we were at 8, and we're going down to 5, so we're going to go down 3. So immediately we can sort of see that this is going to work. We're going to get that QB is, again, the square root of 4 squared plus 3 squared is equal to 5. So AB equals QB. These 2 little lines we can put in on it. The triangle is isosceles. I think that's the best way of doing it, actually. I was thinking before, getting this, once we get this 3 and the 4, it's kind of like we can sort of see enough that we're going to, because we get a right angle, that they are definitely going to be the same length. I think to be like really sure and convincing in your answer, then using Pythagoras' theorem is a good idea.